The universe isn't endless, but instead there's a wall at the edge. This is a topic that has captured the imagination of scientists and science enthusiasts alike for many years. Before we begin exploring the idea of a wall at the edge of the universe, let's first understand what the universe is. The universe is everything that exists, all matter, energy, and space. It includes everything we can see, touch, hear, and smell, as well as everything that we cannot detect directly, such as dark matter and dark energy. One of the most significant discoveries of the 20th century was that the universe is expanding. This means that galaxies are moving away from each other at an accelerating rate. Scientists first discovered this phenomenon in the 1920s, when American astronomer Edwin Hubble observed that galaxies were moving away from us and that the farther away a galaxy was, the faster it was moving away. This discovery led to the development of the Big Bang Theory, which suggests that the universe began as a single point and has been expanding ever since. According to this theory, the universe is approximately 13.8 billion years old. One of the most intriguing questions about the universe is its shape. Is it flat, like a piece of paper, or curved, like a sphere? Scientists have been trying to answer this question for many years, and the current consensus is that the universe is flat. This means that if you were to travel in a straight line in any direction, you would never return to your starting point. Let's dive a little deeper into the question of whether the universe is endless. As we mentioned earlier, there is no conclusive evidence to suggest that the universe has an edge, but there are several theories that suggest that it might not be endless. One of the main arguments against the idea of an endless universe is that it would violate the laws of physics. According to the laws of physics, matter and energy cannot be created or destroyed, only transformed from one form to another. This means that if the universe were truly endless, it would mean that there was an infinite amount of matter and energy, which would be impossible. Another argument against the idea of an endless universe is that it would mean that the universe was infinite in age as well. This would mean that the universe had been around forever, which would also violate the laws of physics. However, there are also arguments in favor of the idea of an endless universe. One of the main arguments is that the universe could be curved in such a way that it appears to be endless. For example, imagine that you're standing on the surface of the Earth. If you were to walk in a straight line, eventually you would end up back where you started. However, from your perspective, it would appear that you were walking in a straight line and that the Earth was endless. The same could be true for the universe. It could be curved in such a way that it appears to be endless, even though it's not. Another argument in favor of the idea of an endless universe is that it would make sense from a philosophical standpoint. If the universe had boundaries, then what was beyond those boundaries? And if there was nothing beyond those boundaries, then what was the point of those boundaries in the first place? From a philosophical perspective, it makes more sense to think of the universe as being endless, as it allows us to avoid these kinds of questions. So, is the universe endless? The truth is, we don't know for sure. While there are arguments both for and against the idea of an endless universe, there is no conclusive evidence to suggest one way or the other. The concept of an endless universe is still a subject of debate and research in the scientific community, and who knows what we may discover in the future. One of the most significant pieces of evidence for the Big Bang Theory is the cosmic microwave background radiation. This is a faint glow that pervades the entire universe and is thought to be the residual heat left over from the Big Bang. Scientists have been studying this radiation for many years, and they have discovered that it is incredibly uniform. This means that the temperature of the radiation is almost the same in all directions. However, in 2013, scientists studying the cosmic microwave background radiation discovered an anomaly. They found that the radiation was slightly colder on one side of the sky than on the other. This discovery has led to the development of several theories, one of which suggests that the anomaly could be the result of the universe's shape. According to this theory, the universe could be curved like a sphere, and the anomaly could be the result of us seeing a part of the universe that is just starting to curve away from us. Another piece of evidence that suggests that the universe might not be endless is the Great Attractor. The Great Attractor is a region of space that has been intriguing astronomers and physicists for decades. It was first discovered in the 1970s, when scientists noticed that the motion of galaxies in our local group was not random, but was instead being pulled towards a specific point in the sky. Initially, scientists thought that this point of attraction might be caused by a supermassive black hole at the center of the Milky Way galaxy. However, further observations showed that the point of attraction was actually located far beyond the Milky Way. The Great Attractor is located in the direction of the constellation Centaurus, about 250 million light-years away from us. It is a massive cluster of galaxies, estimated to contain tens of thousands of galaxies, that is pulling everything in its vicinity towards it. One of the reasons that the Great Attractor has been so difficult to observe is that it is located in a region of space that is obscured by dust and gas. This means that traditional telescopes, which rely on visible light, are unable to see it. Instead, scientists have had to use other methods to study the region, such as infrared and radio telescopes. One of the most intriguing aspects of the Great Attractor is that it seems to be moving relative to the cosmic microwave background radiation. The CMBR is the afterglow of the Big Bang, and it is thought to be the oldest light in the universe. It is also incredibly uniform, with temperature fluctuations of only a few millionths of a degree. However, scientists have found that the Great Attractor is moving relative to the CMBR at a speed of around 600 kilometers per second. This means that the Great Attractor is not just a static object, but is actually moving through space, which makes it even more mysterious. Despite decades of study, scientists are still trying to understand the nature of the Great Attractor. Some have suggested that it could be a supercluster of galaxies, while others have suggested that it could be the result of a collision between two massive galaxy clusters. Another theory is that the Great Attractor could be the edge of the universe, beyond which there is nothing. This theory suggests that the gravity of the Great Attractor is so strong that it is pulling everything in the universe towards it, and that beyond the Great Attractor there is nothing but empty space. This theory is highly speculative and has not been proven. It is also important to note that the Great Attractor is not the only region of space that is attracting galaxies towards it. There are several other clusters of galaxies that are also causing gravitational disturbances in the universe, and it is possible that the Great Attractor is simply one of many. Another theory that suggests that the universe might not be endless is the multiverse theory. This theory suggests that there are multiple universes, each with its own laws of physics and properties. The multiverse theory is a concept that has fascinated scientists and science fiction fans alike for decades. At its core, the multiverse theory suggests that there may be multiple universes, each with its own unique set of physical laws, properties, and possibilities. The multiverse theory is based on the idea that our universe is just one of many possible universes that exist. According to this theory, there may be an infinite number of universes, each with its own set of physical laws and properties. These universes may be similar to our own, with minor differences in the laws of physics, or they may be vastly different, with completely different properties and possibilities. One of the most common ways that scientists have explored the concept of the multiverse theory is through the concept of parallel universes. These parallel universes are imagined to exist alongside our own, with different versions of ourselves and different possibilities. For example, in one parallel universe, we may have made different choices in our lives, leading to different outcomes and experiences. There are several different theories that suggest the existence of multiple universes. One of the most popular is the many-worlds interpretation of quantum mechanics. According to this interpretation, every time a quantum measurement is made, the universe splits into multiple versions, each corresponding to a different possible outcome of the measurement. Another theory that supports the multiverse theory is the idea of inflationary cosmology. This theory suggests that in the early moments of the Big Bang, the universe expanded at an incredible rate, creating multiple bubbles of spacetime. These bubbles could be thought of as separate universes, each with its own unique set of physical laws and properties. While the idea of the multiverse theory may seem like science fiction, there is some evidence to suggest that it may be true. For example, scientists have observed anomalies in the cosmic microwave background radiation that could be explained by the existence of other universes. Additionally, some physicists have suggested that the properties of our own universe may be explained by the existence of other universes. In the end, the true nature of the universe remains a mystery, and we may never know for certain whether it is endless or has boundaries. But that doesn't stop us from continuing to explore and uncover the secrets of the universe, and who knows what we may discover in the future. Thank you for joining us today, and we'll see you in the next one.